Before there were stars, planets, or even atoms as we know them, the universe had a brief window, just a few minutes, to cook up its very first ingredients. This early fusion event is called Big Bang Nucleosynthesis, and it sets the stage for everything that came next. Big Bang Nucleosynthesis, or BBN, refers to what happened during the first 3 to 20 minutes after the Big Bang. During that time, the universe was incredibly hot and dense, hot enough for nuclear fusion to begin. But it didn't last long. As the universe rapidly expanded and cooled, that brief fusion window closed. In that short time, the earliest elements were born, mostly hydrogen and helium, with traces of lithium and beryllium. At just 1 second old, the universe cooled enough for protons and neutrons to form. Then came fusion. These particles began sticking together, creating simple nuclei. Helium-4 was the most stable product, but small amounts of deuterium, helium-3, and lithium-7 also formed. Heavier elements like carbon or oxygen couldn't appear yet. The universe cooled too fast for those to fuse. By the time fusion stopped, the universe had made a basic recipe. About 75% of the mass was hydrogen, mostly as lone protons. Roughly 25% became helium-4, and a tiny fraction, less than 0.01%, was deuterium, helium-3, and lithium-7. These primordial elements were simple, but they were the raw material from which stars, galaxies, and eventually planets would form. Today, we can observe these ancient elements in old gas clouds and stars, and their ratios match what the Big Bang nucleosynthesis predicts. That agreement is one of the strongest pieces of evidence for the Big Bang theory. BBN helps us understand how matter first took shape and why heavier elements had to wait for the first stars to ignite. It reminds us that everything, from stardust to humans, started with just a few simple atoms, forged in the very first minutes of time. Thanks for watching, and make sure to like and subscribe for more videos.